In this video, we will discuss the details of designing a class in Java. Designing complex systems with multiple classes that interact with each other can become complicated. Therefore, to model and describe the system structure, programmers use a language called the Unified Modeling Language, or UML. UML is a standardized modeling language that can help visualize the system design and the structure of the system, which consists of classes. What we will do is to adopt the UML graphical representation of classes and use it to represent the model of our classes. This will help us develop a systematic and straightforward approach to designing classes. In UML, a class is represented as a rectangle with three parts. The first represents the name of the class. The second part represents the attributes of the class, which are also called fields. The last part represents the methods of the class. The idea is that once we have a UML class design, we can translate that to a Java code. Now our task is simple. As we design a class, all we need to do is to think of these three parts. What is a good concise descriptive name we can use to name the class, from which we will create our objects? What are the attributes that I need to consider? These are the features of the object under consideration. For example, if I'm writing a class to represent cars, I can include the make, the model, color, and VIN number. I also need to decide on whether other classes can access my attributes or not. Finally, we need to design the methods that will allow the outside world to interact with our object. Should other classes read my data, then I create a method to let them do that. Should other classes have access to set or change my data, I should also describe how to do that in my methods, and so on. Alright, let's take a practical example and use it to write our first class in Java. Assume we want to write a simple class to represent a rectangle shape. The name that we pick for this class should be concise and descriptive. In this case, nothing is more straightforward than the name rectangle to represent rectangles. Excellent. Now we should think about the data or the attributes of my class. When you think about the attributes, you need to ask yourself, what information should I maintain that fully describes my object? So if you think about a rectangle, for example, you can describe a rectangle using its length and width. That's it. Then all we need to keep track of is the length and width. Now notice that you could talk about the area or the perimeter of the rectangle. However, these attributes are derivatives of the length and width. So keep it simple and stick to the length and width. Now, what if I told you I have two fields, length and width? As a Java programmer, do you feel that this information is sufficient? You shouldn't. You should ask me, what are the data types of these fields? To keep the numbers flexible, we will set the fields to be double. Also, you should ask me, who can access these fields? Remember, the access modifier specifies who has access by setting it to public, private, or protected. Also remember that the goal of object-oriented programming in the first place was to hide and protect the data. Therefore, the data in most of the cases are set to be private by default. To do that in UML, instead of typing private, you use the minus sign. The positive sign represents the public and the hash or pound sign represents the protected. So in our case, we will set the length and width fields to be private. So we end up with a minus to represent private access modifier, name of the field, followed by a colon, and then the data type. Now we are done with the name and the fields of the class. Next, we need to think of the methods. Notice that what we are doing is the application of the encapsulation concept. It makes our class not only self-contained, but also self-governed. What does it mean to be self-governed? What it means is that by setting the fields to be private, you need to define the methods through which outside classes interact with your fields. We set the rules. First, we need to ask ourselves, what would an outside class want to do with our attributes? You will find that it's one of two things. Either to modify it by setting a value to it. In this case, we need to define a setter method, a method that sets the value of our attribute. This type of method is also referred to as the mutator method, since it helps mutate the value of the attribute. Another possible interaction between the external classes and our attributes is that they want to access the data without changing them, just read them. In other words, to read the attribute's value. In this case, we need to define a getter method that gets the data to the requesting class. Getters are also referred to as accessors, since they access the data and read it. Now, since we set our fields to be private to prevent anyone from accessing it directly, we will need to set our methods to be public. This way, an external user can use it and interact with our class. Notice that our class will be like an isolated island if we set the fields and the methods to be private. Therefore, the methods are usually set to be public unless they are not intended for external use, in which case we can set it to be private or protected. Excellent. Let's define some methods then. To declare a method, you need to use its header format. The header includes the access modifier, public, private, or protected. It also includes a return type, a method name, and parameters. To understand these new terms for us, let's take a very simple example. Assume that you want to write a method called adder that accepts two integer numbers, a and b, and it returns or outputs the sum c of the two numbers. Alright, one way to think about it is to say my method is like a box that I will name adder. It takes two inputs, a and b, it calculates the end sum, which is a plus b, and stores it in c. Then it outputs c. So how does that relate to my method header? The access modifier, as we said, will be set to public. The method name is simple, it's called adder. The parameters are the inputs the method needs to operate. This includes the data type. The return type is the type of the data you expect to get from the method. Notice that it doesn't care about the name you used inside the method, it only cares about the type of C, which is int. Finally, the method body is what you executed inside the box to get the output. Alright, let's now write a method that operates on our rectangle class. We want to write a method that sets the length field of the rectangle. I will follow the same approach. Draw a box, call it SetLength. Do you think this method needs input? Let's think about it. Since it should set the value of the length field, we need to know what value should it set the length to. So clearly this method will take an input. Let's call it newLength. Now we want to set the length field to the new length value. And this is what we will exactly do inside the body of this method. What about the output? Do you think or do you expect an output from this method? No, we are not expecting an output because the method did its job and already set the length to a new length. Alright, but now we have a problem. The way the header of the methods in Java is defined expects the return data type. But we have nothing returned from the SetLength method. In this case, what you do is to set the return type to be void. Void means you are expecting nothing from this method. Alright, so let's translate this into a Java code. Our method is public, it returns nothing, so we use void, and it's called SetLength, and it takes a parameter of type double called newLength as an input. Inside the method, all it does is that it assigns the new length input to the length field. In UML, this is written as a plus sign for public access modifier, setLength, the name of the method, parentheses that contains the input parameter followed by a colon, and then the data type. The parentheses are then followed by a colon and the return type, which is void in this case. Of course, we can do the same thing for the SetWidth method. We will just replace the input to be new width instead of new length, and also we set the width instead of the length. We are now done with the setters, or what we also call mutators. Let's have a look at the getters or accessors of this class. We want to write a method that gets the value of the length field. Again, let's think of the method as a box called GetLength. We are asking this method to fetch the length stored in the object. So the question is, do we need to give it an input to work? The answer is no, it doesn't need an input. Alright, so what about the output? Do we expect an output? Of course, the length that we asked it to get. Now, how does the method return the length? As we will learn soon, there is a keyword in Java that is called return, which tells the method to return a variable or a value. Alright, let's translate that into a Java code. Notice that the parentheses are empty since the method doesn't take an input parameter. Also notice that the return type is set to double since we are returning the length, which was declared to be of type double. And in the body of the method we say return the length. Java will understand this return as a keyword and it's going to return the length as an output from this method. To translate this method to the UML diagram, we use the plus for the public access modifier. The method is called GetLength with empty parentheses for no inputs, followed by a colon and the return type, which is double in this case. Now we have a complete UML diagram for our rectangle class. How do we translate this into code? It's effortless. Just follow the same structure of the UML. The name of the class will set the header of the class. Then follow it with the list of attributes. The minus sign translates to private keyword, followed by the data type, and then the name of the attributes. Start writing the methods: SetLength, SetWidth, GetLength, and GetWidth. Now we have a complete Java code for the class describing a rectangle object. What we need now is an application to utilize this class by instantiating objects from the class. So let's write this application, or what we call the driver program. Since the driver program should be contained in a class, I'm going to call this class the rectangle demo as a demonstration for how to use the rectangle class. To make it an application, I will declare the main method. Inside the main method, I will use the rectangle class by creating a rectangle object. The first line, which tells Java to create a new object from the rectangle class and reference it with the reference variable box. Notice that the rectangle object in the memory has the two fields length and width ready. It also has the four methods we declared in our blueprint class. When you execute box.setWidth20, what will happen is that the SetWidth method will work. It will take the 20 and sets the width of the object we created to be 20. Similarly, SetLength will activate the SetLength method and sets the length of the parameter to be 10. If you use getWidth, the method getWidth will work, get the value of the width, which is 20, to the print line statement. Similarly, getLength will return the 10 to the second print line statement to be printed. Now that we understand how all of this works, we will simplify our representation of objects and represent them with boxes. This is the end of the video. However, I have a question for you before I conclude it. If we meant to protect the data, the length and width in this example, how can we go and define methods that give full access to external users to read and write the values of my attributes? Although external users have full access to our attributes, the keyword here is that we defined. We chose to give access and we can choose not to do that. For example, we could allow users to set length but can't set the width. This is the key to encapsulation. Now you have control over your data.